I was having some issues with my projector this week, so I didn't get a chance to record all the videos from class, but I wanted to go through some of the concepts in Chapter 2 just so you have them. So let's start with a conditional statement. So a conditional statement is a statement that involves a hypothesis and conclusion. So sometimes these conditional statements are in if-then form. So we talked about things like, if I could paint a flower in a huge scale, you could not ignore its beauty. So it involves something called a hypothesis and a conclusion, so you could not ignore its beauty. Okay, so that is definitely an if-then form, but it's not always an if-then form. So you might have something that says, a great work is made out of a combination of obedience and liberty. So you could write it in if-then form by saying, if a work is great, then it is made out of a combination, and so on, of obedience and liberty. So the hypothesis would be a work is great, and the conclusion would be it is made out of a combination of obedience and liberty. All right, so we had some practice on these. So it says rewrite the following conditional statements in if-then form. So I'll kind of go through these, but I'm not going to write it down. So number one, so a number divisible by 25 is also divisible by 5. So we would say if a number is divisible by 25, then it is also divisible by 5. Number two, a person over the age of 16 and a half is eligible for a driver's license. If a person is over the age of 16 and a half, then they are eligible for a driver's license. The next one, where all think alike, no one thinks much. So if all people think alike, then no one thinks much. And two angles have the same measure if they are congruent. So this one's a little bit different because the if part happens at the end, so the hypothesis is at the end of the sentence. So we would say if two angles are congruent, then they have the same measure. All right, so the converse. The converse happens when we switch the hypothesis and a conclusion. So when it's in the if-then form, you would just switch the then part to the front of the statement to be the new if part. So a converse, I told you to remember converse sneakers. We move things around. So we move around. So the first example says, if you go to Cathedral High School, you are required to wear a uniform. So we say, if you are required to wear a uniform, then you go to Cathedral High School. Okay, and we talked about that in class. We said, well, not all schools, it's not just Cathedral that requires a uniform, maybe like Heron High School or the Oaks Academy or something like that. There's other places where you would have to wear a uniform. Okay, so that converses are not necessarily true. So this one would be false. Okay, but they're not always false. So like number two works. It says if a number is divisible by 2, then it's an even number. So we would say if a number is an even number, then the number is divisible by 2. That works. So the converse of that statement is good. Okay, so then we started talking about negation. So negation is where you put in nots, basically. So it says the statement has the opposite meaning of the original statement. So alter the statements by negation. So the angle is acute. And we talked about, well, you can't say the angle is obtuse because what if it was a right angle? What if it was a straight angle? So we would just say the angle is not acute. Okay, and same thing for number 2. The measure of the angle is not 50 degrees, right? But don't get too not happy. Like this next one, it says every student at University High School arrived on time today. If that's false, if every student did not come on time today, then we don't want to say every student at University High School did not arrive on time today because that's a little bit strange. Does that mean that every single person was late? Doesn't make any sense, right? So oftentimes the opposite of every is at least one. So the way we're going to do this is we're going to say at least one student at UHS arrived or did not arrive on time, or we'll say arrived late today. Oops, today. Okay. So the next one. So it says the inverse of a conditional state negates the hypothesis and conclusion. So we're going to do the not for the if part and the then part. Okay, so inverse I always write as inverse because we negate things Okay, so the inverse. So it says, if you are chewing gum here in high school, then you receive attention. So number 2. So we're going to say, if you are not chewing gum at HHS, then you do not receive a detention. Okay, but there could have been other reasons you received a detention. So there's lots of things you could have done to get a detention. So maybe you weren't wearing your uniform or something like that. Okay, so this one's also false. Okay, so both the converse and the inverse are not necessarily true statements. When you converse, when you switch it around, inverse when you negate it. So putting it together, though, the contrapositive, that's a combination of the converse and the inverse. It's both of them. And that one's actually always true. So that's the only one that's always true. So it says write the inverse, the converse, and contrapositive of the 3 statements. So for number 1, I'll just run you through this. I won't write it, but you can listen. So it says, if you play the piano, then you are a musician. So the inverse would be, if you do not play the piano, then you are not a musician. We put in the nots, right? The converse is where we switch. So it says, if you are a musician, then you play the piano. And that one also doesn't work. Okay, so the first one was if you do not play the piano, then you can't possibly be a musician. But maybe you play the flute or the harp or something else. You could be a musician, right? And the converse, when we switched it, if you are a musician, then you must play the piano. Well, no, you don't necessarily have to play the piano to be a musician, right? And then the contrapositive puts it together. So the contrapositive would be, if you are not a musician, then you do not play the piano. So it puts it together, both the inverse and converse together. And that's the only one that's true. If you're not a musician, then there's no way that you could possibly play the piano because you would be a musician then, okay? So same thing for the next one. If the batter gets 3 strikes, then the batter is out. The inverse is, if the batter does not get 3 strikes, then the batter is not out. The converse is, if the batter is out, then the batter gets 3 strikes. And the contrapositive is, if the batter is not out, then the batter did not get 3 strikes. And that's the only one that's true. Okay. So it says decide whether the following statements are true or false. If it's false, give a counterexample. So a counterexample is where we, give an example that proves it wrong. So 2A says a line can be in more than one plane. So I think that's true. A line can be in more than one plane. And an example would be like if I was drawing the classroom out, the front wall and the side wall, this line is in 2 planes, right? Or if I draw like the spine of a book. So I have all these pages in the book, right? The line that's right here as the spine of the book, that's in all of those planes, okay? So this one is true. The next one, 2 non-intersecting lines can be non-coplanar. So can we have 2 lines that don't intersect that are not in the same plane? Sure. So we could have this line and this line. So 2 skew lines, right? Those would not be in the same plane. But we could not have these 2 lines. So some people will think those 2, but there's actually a plane that includes those. It's like the diagonal plane there. So it wouldn't be those 2 lines. It would have to be like the skew lines. Those can be non-coplanar. So this is true. So you could have skew lines. All right, so let's see if there is some more in section 2.2 that we need to go over. So a biconditional statement is a single true statement that uses if and only if that combines a true conditional and also its converse, but only when the converse is also true. So it says write the converses of the following true statements. So if you receive at least a 70% in geometry, then you pass the course. So we would say if you pass the course, then you receive at least a 70% in geometry. And that's true. So at university, if you are passing, then you had at least a 70%. So we're going to combine this So if it's true, we combine to form a biconditional. So that's where we have if and only if. So we're going to say you receive, so we don't start it out with if this time, at least a 70% if and only if you pass the course or pass geometry, right? Okay, so in the middle is where we put our if and only if for the biconditional. So it says if two lines are skewed, then they are not parallel and they do not intersect. So the converse would be true. So if two lines are not parallel and do not intersect, they must be skew lines. And the biconditional would be two lines are skew if and only if they are not parallel and do not intersect. All right, so it says all definitions can be interpreted both forward and backwards. So definition should work with the biconditional. So it says if two lines are perpendicular, then they intersect to form a right angle. But we can also say if two lines intersect to form a right angle, then they are perpendicular. Okay, so we could combine those because both of those are true, so we could combine those into an if and only if statement. So we could say two lines, are perpendicular if and only if, which you might see as IFF. Sometimes you write out if and only if as IFF. So if and only if they are perpendicular. Or wait, if they intersect to form a right angle. I got sidetracked. So if they intersect to form a right angle. So we have the if and only if in the middle. That's why it's a biconditional. So biconditional means we can have the forward statements and the backward statement. The original conditional statement and its converse are both true. All right, so let's skip these definitions and let's go to some of these. So it says decide if each statement is reversible. If it is reversible, write it as a biconditional. If it's not, then write not reversible. So this one, so we want to decide if the converse is true. If the converse is true, it will be reversible. So we're going to say if x is equal to 2 or x is equal to negative 2, then x squared equals 4. So that's true. So it is reversible. Okay, so if it's reversible, then we can write it as a biconditional. So the biconditional, we would say x equals 2 or x equals negative 2 if and only if x squared equals 4. So we could write it like that, or we could say x squared equals 4 if and only if x equals 2 or x equals negative 2. It doesn't matter which order we write it in. All right, so parallel lines are planes that do not intersect, or parallel planes are planes that do not intersect. So that would be true, right? Parallel planes do not possibly intersect. There's no such thing as like skew planes. That can't be possible. So that means that the biconditional would work. So planes that do not intersect. So the converse would be if planes do not intersect, then they are parallel planes. So the biconditional would be planes are parallel if and only if they do not intersect. Okay, so you could go through all of those. So number 5, it says, is each statement below a good definition if not explained? So definitions, like we said, should go forwards and backwards. So a rectangle is a figure with two pairs of parallel sides. Can we say a figure with two pairs of parallel sides is definitely a rectangle? No. So we could have a parallelogram. That would not be a rectangle. So no. A segment is a portion of a line. Well, not necessarily. We could have a ray, right? So this is not a good definition. So a portion of a line is not always a segment. Parallel lines do not intersect. Again, going back to the skew lines. Like maybe I have this line here, and then I have the line in the front. Those are not going to intersect. So this would still be no. And then the last one is the only one that's a good definition. So a midpoint is the point that divides a segment into two congruent segments. So this is yes. Because the point that divides a segment into two congruent segments is said to be a midpoint. It works backwards as well. Okay. Let's stop there, and then we'll do 2.3 in another